There's been a lot of talk about artificial intelligence in the press recently. Everything from taking 90% of all jobs to Skynet destroying humanity. I think it's worth coming back to a great question which I answered and expanded upon in my live stream and looking at the limits of what this technology can do. First of all, we already have solutions for many problems which are better than any AI could hope to be. Something as simple as converting temperatures from Celsius to Fahrenheit requires 2 floating point operations, which a computer can already do very well. More complicated tasks, such as MP3 encoding, which is actually very interesting and I will cover it in my next video, are solved perfectly well by our existing algorithms. Consider even more conceptual tasks, such as finding a route between 2 points on a map. The neurons of a taxi driver used to do this every day, and a neural network can certainly be trained to do so. Occasionally, the neural net would make a mistake, while Dijkstra's algorithm is guaranteed to find the mathematically optimal solution every time. AI is not magic. It will still have a certain finite computation time. For many applications where reaction times are important, neural networks would be a worse choice than an ordinary algorithm, a digital component such as an ASIC, which is tailor-made for that particular problem, or even an analog device. AI is also bound by the laws of physics, so that it won't somehow invent faster than light travel. It doesn't so much add new capabilities as simply expand and replicate existing ones. For example, AI for autonomous vehicles is currently nowhere close to the driving ability of Lewis Hamilton, who not only won many Grand Prix, but also can navigate busy traffic and narrow streets. Anyone who can create a self-driving car as good as a Grand Prix winner would become wealthy indeed, but wouldn't add a capability which humanity didn't have before. We already had one car being driven by Lewis Hamilton. This would just allow many more to be driven simultaneously. This hits on a larger misconception that AI will become a genius and solve all the world's problems, or destroy humanity purely through its intellect. This is just not how science, technology, economics, or politics work. Success is predicated upon perseverance and often comes only after multiple failures. Even something purely conceptual, like mathematics Olympiad questions, often require experimentation. You might try to factorize, make a substitution, and so on before getting the answer. Yes, computers excel at running through many calculations quickly, but for any problem with practical applications, the limiting factor is the speed of physically building and organizing things. For example, SpaceX has recently tested their new Starship rocket. It took off successfully, but failed with stage separation and exploded. The test would not have worked any better if the engineers had been super intelligent or got higher scores on their exams or whatever. To make one successful rocket, you have to physically build and crash several prototypes beforehand, not least because chaos theory makes it impossible to predict how a complex system will behave from intellectual reasoning alone. This is all assuming that an artificial general intelligence can even be constructed out of deep convolutional neural networks and then trained. Right now, the technology suffers from the usual problem of curve fitting. It's great when working between existing data points, namely things it has already learned, but bad when extrapolating out further, like developing totally original ideas. Moreover, there is an assumption that such an intelligence would immediately want to secure world domination. If it is trained on human behavior, particularly as seen on the internet, it would much more likely desire a balance between acquiring fast cars and jewelry, amassing likes on Twitter, and finding out the winner of the next Love Island or whatever. A supposed superintelligence, whether stemming from technological or biological means, is not going to have such a large an effect on the world as people have suggested. I stopped believing in the concept of genius a long time ago. Historical figures like Isaac Newton were very much products of their time, building upon previous work. In other words, Newton did not make his discoveries because he was the most super intelligent person born up to that point in history. He did so because other discoveries had only just been made, and because the changing socio-political structure of the time allowed him to think instead of tilling the fields all day long. Newton also believed in weird occult things and lost a bunch of money in the South Sea stock market bubble. Historical dictators have rarely been very intelligent or academic. Democratic leaders are not chosen on the basis of always getting the best degree, owning the most commercially successful company, or being the most charismatic. I've worked with people from leading plasma physics and fusion experiments, from NASA and so on. They did not necessarily get the highest grades in their class. For that matter, how do you even quantify a general level of intelligence? As I say, performance in an exam where the answer is known is not a great indicator for aptitude at tackling real-world unsolved problems. This is an issue we have even for teaching humans. For a neural network, it's easy enough to rate how well it has identified handwritten digits from the Mnist database and therefore to train it to be better. Likewise with generative AI. How, though, do you gauge ability at the complicated process I just talked about, taking existing facts but then solving problems that have never been solved before? In terms of perseverance, it is true that an AI could work around the clock without sleep, but so could 3 teams of humans doing 8-hour shifts. In terms of communication, if an AI mastered geology and metallurgy simultaneously, it wouldn't need to spend time talking, unlike 2 human experts in these fields. Again though, this is just speeding up what we can already do, not building any emergent capability. It's also hard to see a scenario where only a single monolithic AI emerges, rather than disparate ones belonging to different companies or organizations. Suppose you had an AI representing a steel mill supplying materials to an AI representing a car factory. There would still be a communications barrier because each one would still need to critically assess what the other is telling it, an adversarial system. Otherwise, one of the two could game the system and take advantage of the other. There have been years of discussions about how to prevent adversarial attacks on AI, where image classifiers, for example, are tricked. We may also find that to really solve original problems, multiple adversarial and differently trained neural nets would need to effectively debate with each other and with us in the same way that many innovations have come from teams of people with different complementary personalities. To summarize, consider 3 intellectual problems. Firstly, look at calculating the length of the hypotenuse of a right-angled triangle. Anyone from a high school student to a mathematics professor can solve this. Beyond a threshold level of mathematical understanding, increased intelligence does not help. Existing, straightforward to understand methods are very capable of solving this and many more complicated such problems, often with mathematical certainty. Encryption and root finding are among them. Then there is squaring the circle, a phrase denoting an impossible problem to solve for any intelligence, biological or technological. There are many problems of this type in math, physics, and engineering. Lastly, there are applied problems like building a new rocket. AI certainly can and will aid in this, make development cheaper and easier, maybe require 2 failed launches instead of 3, but logical reasoning alone will not succeed. A theory of everything and a cure for cancer are also in this category. Thanks for watching. This video has been much more opinion-based than previous ones, so I'm interested to see how it's received. I also welcome meta-discussion about the channel itself in the comments. Also, apropos of nothing, here is an example of a perfectly well-tuned, real-time analog computation from the 1940s and 50s. The American Sidewinder missile has a heat seeker on the front. When a source of thermal radiation, such as an aircraft, is within its field of view, it produces an electrical signal on a detector. However, this only tells you if a target is somewhere in front of you, not precisely where it is and how to intercept it. To do so, a spinning circular reticle is added. Half of it is 50% translucent, so that when it spins past the image of the target, the electrical signal is halved. The other half is covered by alternating stripes which are either fully transparent or totally opaque. As this part spins past the target, it quickly flips between being obscured and being visible to the detector, so that the electrical signal oscillates. The time at which the signal transitions between oscillating and being constant is the exact moment when the edge of the translucent half has just swept past the image of the target. If the translucent half is on the right side at that moment, you should go upwards. If the translucent part is on top, you should go left, and so on. As for the stripes, if the target is at the edge of the field of view, then it will alternatively be fully obscured or fully visible. The change between the two, the amplitude of the oscillations, is large. If the target is close to the center, there is little change and the amplitude is small. Therefore, if the amplitude of the oscillations is high, you should adjust your course very hard to intercept the target. But if the amplitude is small, you are basically flying in the right direction. As usual, I have simplified things, but with the right signal processing, this method will work without needing neural nets or image recognition. I thought it was pretty cool.